Imagine stepping into a world where the land stretches endlessly in every direction, where no oceans split the continents, and every horizon leads to more unbroken Earth. In the next few minutes, we're traveling back, not just years or centuries, but hundreds of millions of years into a time before any map you know could exist. Tonight, I'm inviting you to leave behind the world you recognize and step into the age of a colossal supercontinent known as Pangea. You might have heard the name in passing, perhaps in an old-school diagram or whispered by a narrator in a nature documentary, but few truly picture it. So, let's do that together. Close your eyes and imagine standing in a vast land with no familiar borders, no seas to divide continents. The air is different, the ground beneath you ancient, the world around you strange yet full of life. Here, the Americas, Africa, Europe, and Asia are all part of one continuous mass. You could begin a journey in what we now call North America, walk east into Europe without seeing a drop of ocean, and keep going into Asia and Africa without ever touching a boat. Turning south could carry you into what would one day become South America, still without an ocean on the horizon. This land was wrapped on all sides by a single endless ocean, encircling it like a ring. But don't mistake it for a still, quiet place. Beneath its surface, Earth's restless heart never stopped beating. Immense geological forces pushed colossal slabs of crust together, welding them into one. Mountains rose from the ground, valleys cracked open deep into the earth, and volcanoes launched fire and ash into the skies. At the core of this gigantic land, life adapted to conditions foreign to us today. Far from any coast, the climate was unforgiving. Without seas to carry rain inland, vast regions became dry wastelands. Summers were scorching, baking the soil under relentless heat. Winters were bitterly cold. Seasons were bold. The skies stretched endlessly, and the only breaks in the horizon came from jagged mountain silhouettes or stubborn forests that had learned how to survive here. In these challenging lands, life still thrived. Towering plants, crimson deserts, enormous dragonfly-like insects, and strange reptiles that hinted at the first mammals. What truly made Pangea remarkable was its unity. In a world without oceans cutting through continents, the same rivers could snake across what would later become separate lands. Forests stretched without end. Animals roamed freely from one corner of the supercontinent to another, without barriers or borders. It was one connected Earth, a world we can barely imagine today. But nothing on our planet lasts forever. The same tectonic forces that stitched Pangea together were conspiring to tear it apart. Slowly but inevitably, mountains rose only to crumble, oceans closed only to open again. While Pangea existed, it shaped life's evolution and carved the raw foundations of the world we recognize. To truly understand Pangea, we need to rewind back before it formed to the invisible forces that drew it together. Earth's solid surface is broken into enormous plates, slowly floating atop a molten underlayer. Each year they creep by just centimeters, but over millions of years this movement transforms the globe. Before Pangea, other supercontinents like Rodinia and Nuna formed and fractured in the same endless cycle. Over vast stretches of geologic time, smaller continents collided like puzzle pieces, fusing into larger land masses. Mountains were thrust skyward, ranges stretched endlessly, and deep scars were etched into the crust, marks still hidden beneath our feet today. Eventually, all pieces merged into one land so enormous it defies comprehension. Picture yourself in its center. The nearest ocean is thousands of kilometers away. There's no salt in the air, no damp sea breeze, just a deep continental heartland where seasons could swing from sweltering to freezing, where isolation was complete, and where the Earth's scale was almost too vast for the human mind to grasp. This profound isolation didn't just create harsh conditions, it forged an entirely new kind of life. Picture insects the size of small birds buzzing through thick, oxygen-rich air. The atmosphere held far more oxygen than we breathe today, allowing dragonflies to stretch their wings nearly a meter wide as they soared above ancient swamplands. Reptiles evolved incredible survival skills, learning to endure the scorching heat of Pangea's vast interior deserts. Meanwhile, along the distant coastlines, primitive forests created green pathways where life could flourish and spread. Within this massive laboratory of extreme climates and unbroken landscapes, evolution was working overtime. The ancestors of dinosaurs, mammals, and the first birds were all taking their earliest steps toward existence. Pangea wasn't just a continent, it was life's testing ground where every creature that survived would shape the future of our planet. The land itself told stories of constant transformation. Volcanic eruptions painted the sky in brilliant reds and oranges, raining ash that enriched the soil below. Mighty rivers carved deep valleys, carrying precious minerals from towering mountain ranges down to sprawling lowlands. Deserts swelled and shrank with the changing seasons, creating a world that never stood still despite being locked together as one. Even the wind behaved differently in this unified world. Today our oceans act like barriers, breaking up and redirecting air currents around the globe. But in Pangea's time, winds could race across thousands of kilometers without interruption. Desert dust from the heart of the continent could travel all the way to coastal forests, delivering nutrients across impossible distances. Storms grew larger and traveled farther, unbroken by oceanic boundaries. The planet's entire weather system was shaped by this simple fact: nearly all land existed in one massive piece. Every sunrise in this ancient world illuminated horizons shaped by a single connected Earth. There were no mysterious continents hidden beyond vast oceans, no distant lands to wonder about, just one immense world stretching endlessly under the same sky. But Pangea didn't appear overnight. Long before this supercontinent took shape, Earth was a scattered puzzle of smaller landmasses drifting across deep, ancient oceans. These continental fragments never stayed put, at least not in geological terms. They rode the planet's slow-moving tectonic conveyor belts, colliding to build mountains, splitting apart to birth new seas. Each movement took millions of years, but every shift brought them closer to their ultimate destiny, becoming one. Travel back roughly 300 million years to the late Paleozoic era, and you'd find several massive continental blocks already wandering toward each other. There was Laurentia, destined to become North America. Gondwana held the future territories of South America, Africa, Antarctica, Australia, and India. Smaller pieces like Baltica and Siberia drifted separately. They weren't connected yet, but they were on an inevitable collision course that would eventually unite them in one colossal embrace. This wasn't Pangea's first attempt at unity. Earlier supercontinents had tried and failed. Rodinia existed nearly 1 billion years ago before shattering into fragments that scattered across the globe. Those pieces later regrouped into another supercontinent called Pannotea, but it too broke apart after a relatively short existence. These repeated cycles of coming together and splitting apart reveal Earth's natural rhythm, what geologists call the supercontinent cycle, driven by the restless movement of tectonic plates beneath our feet. As these wandering continents crept closer together, the oceans between them began to disappear. The Wreck Ocean, once separating Laurasia, an early merger of North America and parts of Europe from Gondwana, slowly narrowed over millions of years until it vanished completely, crushed out of existence by the converging landmasses. When continents collide, the impact isn't gentle. Rock crumples under unimaginable pressure, and entire mountain ranges thrust skyward where plates lock together. The Appalachian Mountains, stretching across North America and sections of Africa's Atlas Mountains, are living scars from these ancient crashes, permanent reminders of the collisions that stitched Pangea together. From space, this slow-motion planetary transformation would have looked surreal. Massive landmasses creeping toward each other across an enormous global ocean called Panthalassa. Island chains disappeared, their volcanic peaks crushed between colliding plates. Shallow seas vanished. The boundaries between separate continents blurred until they became indistinguishable, one unified land. While this geological drama unfolded, the climate was transforming too. Massive ice sheets clung to parts of Gondwana, especially in regions that would eventually become South America, Africa, and Antarctica. Rock evidence, scratches carved by ancient glaciers, tells us that even during Pangea's formation, Earth swung between freezing and warming periods. As continents crashed together and eliminated smaller seas, ocean currents shifted dramatically, and the atmosphere found new rhythms. These weren't minor background changes, they reshaped life itself. Continental collisions create vast highlands and mountain ranges that redirect winds, trap moisture on one side while casting rain shadows across the other. Even before Pangea fully formed, these shifting landscapes were already guiding evolution's path. Standing on Earth during this transformation, you'd witness landscapes both familiar and alien. Enormous lowland swamps stretched across what would become North America and Europe. Towering forests of primitive trees reached toward the horizon, the famous Carboniferous forests, so dense and humid that their decaying remains would eventually form the coal deposits we mine today. The oxygen-rich atmosphere allowed insects to reach incredible sizes, with dragonflies spreading meter-wide wings as they glided above those ancient wetlands. Massive millipede-like arthropods, some stretching longer than a human arm, crawled across the forest floor on dozens of tiny legs. This was an Earth bursting with experimental life, a planet still discovering what forms life could take. Meanwhile, far to the south, Gondwana painted an entirely different picture. Much of this massive landmass hugged the polar regions, where glaciers carved deep scars across its frozen surface. These icy wastelands couldn't have been more different from the steamy equatorial swamps, yet both existed simultaneously on the same restless planet. As these continental giants crept closer together, climate zones began their slow dance, cold regions sliding northward while warm zones pressed southward, gradually blending into an entirely new global climate system. Then came the final act. Over millions of years, the last great continental crashes began. Laurussia slammed into Gondwana with earth-shaking force, thrusting mountain ranges skyward like crumpled paper. The smaller continental fragments caught between these titans were crushed and absorbed. This was the moment Pangea truly began to emerge, not in a single catastrophic event, but through a long series of collisions and mergers, each impact pushing our planet closer to the world-spanning supercontinent that would define an entire geological era. When this colossal process finally ended, Earth's map would have looked startlingly simple. Nearly every scrap of land on the planet had fused into one massive expanse. Surrounding it, Pantalassa stretched endlessly in all directions, a single global ocean that met the horizon no matter where you stood. Along one edge of Pangea, an inland sea called the Paleotethys still lingered like a stubborn reminder of the ancient oceans that once separated these lands. But even that would eventually disappear, swallowed as the continents pressed together with unstoppable force. The stage was now set. Our world had gathered itself into one unified piece. The final collisions had passed, leaving towering mountains standing guard over the landscape. Deep in the interior, vast deserts were already beginning to form. The climate was shifting into entirely new patterns that would shape life for millions of years ahead. But this was only the opening chapter of Pangea's incredible story. With the continents finally locked together, Earth entered one of the most extraordinary periods in its entire history. Pangea was no longer a concept in motion, it was reality. The slow-motion collisions that had dragged landmasses across thousands of kilometers were complete, and our world now stood as a single unified continent wrapped by an immense ocean. This was an Earth without familiar divisions, and its sheer scale reshaped every aspect of the planet's surface. Creating Pangea meant far more than simply merging continents. It transformed Earth's entire operating system. Where land masses had crumpled together during those ancient collisions, mountain ranges soared skyward. Deep scars in the crust became permanent sutures, welding the fragments into one piece. These geological scars remain visible even today. Modern geologists can still trace them across continents now separated by vast oceans, evidence of places where long ago they were joined as one. The collision zones were absolutely violent. When tectonic plates crash together, the crust doesn't just bend, it folds, fractures, and breaks. Friction builds incredible heat as rock grinds against rock. Molten magma forces its way upward, feeding volcanic chains that can stretch for thousands of kilometers. During Pangea's birth, this process was relentless. The supercontinent's central regions were sculpted by mountain uplifts that rivaled today's Himalayas in their raw power. These ranges would eventually erode, their peaks worn down by countless years. But in their prime, they stood as monuments to our planet's restless energy. Between those towering ranges, vast basins opened like natural bowls, Rainwater and runoff from the newly formed mountains carved extensive river systems, cutting deep channels across Pangea's interior. These rivers fed massive wetlands and deltas that became some of the most fertile regions ever seen. Fossils preserved in these ancient basins tell stories of lush ecosystems that thrived in the shadow of those newly built highlands. But Pangea's formation also created something unprecedented, land on a scale Earth had never experienced. As the continents fused together, the interior of this vast landmass moved farther and farther from the ocean's moderating influence. The result was a continental core so distant from the sea that coastal moisture rarely penetrated its depths. This gave birth to enormous deserts, some potentially stretching for thousands of kilometers without interruption. The heart of Pangea became a land of brutal extremes, a place where blazing summers and freezing winters ruled with iron fists, while the edges near the surrounding ocean remained relatively wet and mild. This pattern of bone-dry interiors and wetter coastlines became one of Pangea's defining characteristics. We can still trace this ancient climate in today's rock record. Red beds, layers of iron-rich sediment formed under hot, arid conditions, are scattered across continents that once formed Pangea's core. These rocks are fossilized footprints of the deserts that dominated its heart. Meanwhile, coal deposits formed in swampy, humid regions tell us that near Pangea's coasts, dense forests flourished under heavy rains carried inland from the sea. Pangea's climate wasn't shaped just by its massive size, but also by its position on the globe. During the supercontinent's peak existence, much of it straddled the equator, creating vast tropical belts that brought intense heat and seasonal monsoons to some regions, while its northern and southern extremes reached deep into polar latitudes. No other land arrangement in Earth's history has ever combined such an incredible range of climates on one connected continent. From frozen southern ice sheets to steaming equatorial rainforests, everything existed on a single continuous piece of land. Life rose to meet these challenges. In warm, wet coastal regions, dense forests of seed ferns and towering conifer-like trees blanketed the landscape. Their roots anchored the soil while their leaves formed vast green canopies that trapped precious humidity. These forests sheltered early reptiles, amphibians, and an incredible array of invertebrates, including insects that reached remarkable sizes. In the harsh interior, life told a completely different survival story. Plants evolved ingenious water conservation strategies, while animals adapted to endure long stretches of scorching heat and desperate scarcity. This became a world where every adaptation was a battle for survival, where each evolutionary change was forged in response to the unforgiving demands of this massive, hostile landscape. But Pangea's formation didn't just reshape the land, it completely transformed the planet's oceans. With nearly every piece of Earth's surface locked together in one place, the surrounding sea, known as Panthalassa, became the dominant global ocean, covering roughly 70% of the planet's surface. This massive body of water circulated around the supercontinent like a planetary conveyor belt, redistributing heat across the globe in patterns we've never seen before or since. Meanwhile, along one edge of Pangea, a shrinking remnant called the Paleotethys Sea persisted. This isolated pocket of ancient ocean became a crucial lifeline for marine creatures, a sheltered haven where coral reefs and shallow water ecosystems flourished, even as the vast open ocean stretched endlessly beyond. It was like a protected harbor in an otherwise overwhelming seascape. This unique arrangement of land and sea created wind systems more powerful than anything our modern Earth experiences. Without the complex coastlines and scattered continents that break up today's airflow, global wind patterns became direct and devastating. Seasonal monsoons swept across vast stretches of Pangea with incredible force, delivering torrential rains to some regions while condemning others to eternal drought. Dust from the interior deserts could travel unimaginable distances, carried by these relentless winds across thousands of kilometers before finally settling into coastal forests or drifting out into the ocean. Perhaps the most profound consequence of Pangea's formation was its impact on the future of all life. By uniting every continent into one massive landmass, Pangea completely erased the barriers that had once kept ecosystems separate. Species that had evolved in isolation for millions of years suddenly found themselves sharing the same vast territory. Predators stalked prey into territories they'd never seen before, plants and animals spread into regions that had previously been completely unreachable. This mixing of life would reshape evolutionary paths for millions of years to come. Today, fossils found in places as far apart as South America, Africa, and India are often nearly identical, living proof that during Pangea's reign, the same species walked freely across lands now separated by entire oceans. It was the ultimate biological melting pot. Even as Pangea appeared to stabilize, it was never truly at rest. Deep within Earth's core, the same tectonic forces that had assembled this supercontinent continued their restless work. Heat built beneath the crust, slowly weakening it in strategic locations. Invisible faults began forming, tiny fractures that would eventually become the starting points for the great breakup that would scatter the continents once again across the globe. But for now, Pangea stood whole, an extraordinary arrangement that dominated Earth's surface and defined an entire geological era. To walk across it, then, would have been to witness our planet in a way no human ever could today. There was no distant coastline hidden beyond the horizon, no mysterious continent waiting across an ocean. There was only one world, vast, connected, and bound together by the same sky, the same powerful winds, and the same restless heartbeat of the Earth pulsing beneath it. And it was here in this unified world that life's next great chapter would unfold. With Earth gathered into one colossal landmass, the very concept of distance was transformed forever. No oceans divided one region from another. No isolated continent sat separated by thousands of kilometers of open water. Pangea was one continuous world stretching from horizon to horizon, unbroken by the familiar boundaries that define our planet today. Picture yourself standing somewhere near the center of that enormous continent. You could walk in any direction for months and never glimpse the glint of ocean on the horizon. Instead, you'd cross plains so immense that the sky seemed larger than it does now. You'd pass rivers that wandered across entire regions, weaving through landscapes without borders. You'd move from one climate zone to another, not because you'd crossed an ocean, but because the land itself was so massive that weather patterns shifted gradually over unimaginable distances. This wasn't a world of isolated ecosystems. In our modern age, oceans create natural barriers that separate species, allowing unique forms of life to evolve on each continent. But on Pangea, those barriers didn't exist. Plants and animals could spread freely, crossing vast stretches of land without ever being stopped by a sea. Fossils prove this remarkable unity. Identical species have been discovered on continents now separated by thousands of kilometers of ocean. Reptiles that once roamed what we call South America also left their bones in Africa. Early plant species stretched across regions that today are scattered around the globe. Pangea allowed life to move as if the entire world were one single connected habitat. The absence of oceanic boundaries also revolutionized how the land itself behaved. Winds could travel incredible distances, unimpeded by mountain chains or fractured coastlines. Massive air currents swept across Pangea, carrying heat and dust from the bone-dry interior toward the distant coasts. Rainfall, however, struggled desperately to penetrate the continent's heart. Moisture from the surrounding ocean would fall as rain along Pangea's edges, nourishing dense forests and wetlands. But by the time those air masses reached the deep interior, they had nothing left to give. What remained were vast arid zones, deserts so expansive they stretched farther than today's Sahara. These dry regions created a stark contrast with the humid belts near the coasts, making Pangea a world of breathtaking extremes. The rivers that cut across this supercontinent carried far more than water. They were highways for life itself. Early amphibians followed these waterways from one region to another, their migrations guided by the steady flow of fresh water. Along their banks, strange forests of ancient conifers and seed ferns created green corridors that connected one part of Pangea to the next. Some rivers were so long that in our time, their courses would cross multiple continents. Yet in Pangea, they were simply part of one boundless landscape. And there were mountains, colossal ranges born from the violent collisions that had created Pangea in the first place. These mountains rose where continents had crashed head-on, their crumpled layers thrust toward the sky like monuments to Earth's incredible power. Some of these ranges were immense, stretching across distances so great they held the land together like geological seams. Over millions of years, erosion wore them down, and their rivers carried sediment into the lowlands, enriching the soil and feeding vast floodplains that supported life across impossible distances. Journeying across this massive supercontinent would have been like traveling through multiple planets without ever leaving Earth. Starting from humid coastal forests, you'd gradually move into sprawling savannas and grasslands that seemed to roll on forever. From there, you'd enter deserts that appeared truly endless, red sands stretching to every horizon, broken only by jagged rocky outcrops and the occasional snaking river cutting through the wasteland. Push even farther, and you might discover forests once again, nourished by mountain rainfall that created their own unique microclimates within the larger continental system. Pangea was unified, yes, but never boring. Its incredible size allowed every conceivable type of landscape to exist side by side, all woven together on one colossal piece of land like a planetary patchwork quilt. The absence of oceanic barriers completely revolutionized animal movement. Early reptiles, the ancestors of creatures that would eventually rule our planet, could migrate enormous distances across Pangea without ever encountering a sea. They spread throughout this vast landmass, adapting brilliantly to its countless environments. Some made their homes in the lush coastal forests, while others mastered survival in the brutal interior. This incredible mobility allowed species to spread rapidly and extensively, creating ecosystems that stretched across much of the entire supercontinent. Even the sky above must have felt alien. On modern Earth, complex coastlines break up wind patterns and create regional weather systems. But on Pangea, the landmass was so enormous that weather systems could roll across it for thousands of kilometers without any interruption whatsoever. Storms that formed near the distant coasts might sweep deep inland, their moisture gradually dwindling until nothing remained but scorching dry wind. Monsoons reached absolutely staggering scales, with seasonal shifts that could drench one half of the continent while condemning the other half to crushing drought. Despite all these challenges, Pangea was far from empty or silent. It pulsed with life. Primitive forests blanketed entire regions that would dwarf modern countries. Coastal swamps teemed with amphibians and early reptiles engaged in their eternal struggles for survival. In the harsh interior, drought-resistant plants anchored the soil against relentless winds, while smaller animals darted desperately between precious patches of shade. Even in its most unforgiving landscapes, life persisted and spread, carried across the continent by its open, unbroken geography. Standing there and looking around would have been utterly overwhelming. No horizon felt close enough to provide comfort. No ocean offered a natural edge to define the world's limits. Everything stretched outward infinitely in every direction, as if the planet itself had somehow grown larger than should be possible. That crushing sense of scale would have defined every aspect of daily existence on Pangea. Travel was painfully slow, movement covered vast distances, and even the endless sky seemed to match the immensity of the land beneath it. This was a world where absolutely everything was connected, where mountains, deserts, forests, and rivers were all part of one single continuous Earth. It was this unity that gave Pangea its incredible power. It shaped global wind patterns and rainfall distribution. It guided the spread of plants and animals across impossible distances. And it set the stage for the next great transformations in our planet's history, when this vast, borderless land would begin to evolve and challenge every living thing that dared call it home. Although Pangea formed one continuous continent, it was anything but uniform. Its edges and interior might as well have been completely different worlds. Along the coastlines, the surrounding ocean's influence shaped everything. Humidity from Panthalassa carried inland on steady winds, nourishing lush forests and swamps where life thrived in spectacular abundance. But the farther you traveled from those life-giving coasts, the less oceanic influence remained. Step by step, kilometer by kilometer, the vibrant green of coastal regions gradually faded, replaced first by open plains and eventually by the stark, arid wasteland of Pangea's enormous interior deserts. The coastal regions were places of constant motion and vibrant life. Warm, shallow seas met the land in extensive tidal flats, transitional zones where the boundaries between land and water completely dissolved. Here amphibians lingered near rivers and wetlands in their eternal search for moisture. Early reptiles stalked prey through forests of towering conifers and ancient seed ferns. Insects, some far larger than their modern descendants, buzzed through the thick, humid air like prehistoric helicopters. The climate in these coastal zones was consistently warm and wet, regulated by the nearby ocean, allowing ecosystems to flourish much like today's tropical rainforests. Fossils from these regions reveal dense vegetation and extraordinary species diversity. Some areas likely resembled modern mangrove swamps, with twisted roots and slow-moving waters teeming with early fish and countless invertebrates. Further inland, but still within reach of the ocean's life-giving moisture, sprawling river systems carve through the landscape, feeding broad floodplains where forests grew thick and emerald green. These regions would have been Pangea's most habitable areas, rich with food and shelter, their seasonal cycles predictable and reliable. But every step away from those coasts carried you closer to an entirely different kind of world. In Pangea's deep interior, rainfall became desperately scarce. The same immense size that allowed Pangea to unite nearly all of Earth's land also gave it one of its most defining and terrifying features: a continental heartland so far from any sea that it became a desert on a scale no modern landscape can match. These weren't small patches of sand like the deserts we know today. They were vast wastelands stretching for thousands of kilometers, broken only by occasional rocky highlands or isolated rivers, fighting for survival. Geologists have discovered evidence of these regions in red beds, layers of iron-stained rock formed under brutally hot, dry conditions. These rocks tell us that much of Pangea's interior was a land of relentless sun and minimal rain, where only the most resilient forms of life could endure. In this interior wasteland, the air would have felt suffocating during the day, with heat radiating off the ground in shimmering waves that distorted the horizon. At night, without the insulating presence of clouds or nearby oceans, temperatures would have plummeted dramatically, leaving the land freezing cold under a canopy of brilliant stars unmarred by any moisture. It was a world of brutal extremes where survival demanded absolute resilience. Plants here were sparse and incredibly tough, their roots digging deep into the earth, their leaves hardened against devastating water loss. Small reptiles and early mammal-like creatures adapted ingeniously to this environment, burrowing underground for shelter or becoming active only during cooler hours to avoid the punishing sun. Between these harsh deserts and the lush coastal forests lay transitional zones, regions of grasslands and open woodlands, where the climate shifted gradually from wet to dry, creating unique ecosystems that existed nowhere else on Earth. These transitional zones became the great superhighways of life on Pangea, corridors that allowed animals and plants to move between completely different parts of the continent, like biological bridges connecting separate worlds. Along these ancient routes, species spread across the entire supercontinent, creating the widespread fossil patterns that modern scientists discover today on continents now divided by vast oceans. Meanwhile, the coastlines themselves were anything but uniform. Some regions faced steady rainfall and supported dense, swampy forests that thrived in perpetual humidity. Others lay trapped in the rain shadows of massive mountain ranges, leaving them significantly drier than their latitude would suggest. Monsoonal winds driven by Pangea's immense size and the seasonal shift of the sun brought alternating floods and devastating droughts to certain coastal zones. The land never stood still. Every year, powerful storms swept inland like clockwork. Rivers swelled to massive proportions and then shrank to mere trickles, while forests adapted to cycles that repeated relentlessly for millions of years. The dramatic contrast between the coasts and interior shaped far more than just the landscape. It completely influenced the behavior of every animal that lived there. Coastal regions were rich in food and supported an incredible range of species. In the harsh deserts, competition was absolutely fierce, and life became hyper-specialized. Fossils reveal creatures in these arid zones with remarkable adaptations, from sophisticated burrowing habits to specialized teeth designed specifically to survive on tough, dry vegetation. Life wasn't evenly distributed across Pangea, but it was profoundly interconnected. Rivers flowing from the mountains to the coasts, winds carrying dust from the deserts to the forests, and the migration paths of animals all tied these environments together in an intricate web. Even the air itself carried traces of this interconnectedness. Dust storms from the interior deserts likely traveled incredible distances, spreading precious minerals across Pangea and even into the surrounding ocean. This constant movement of material linked land and sea, feeding nutrient cycles that help sustain ecosystems on both. To walk across Pangea would have been to pass through these sharp contrasts from the wet, teeming forests of the coasts to the empty, sun-baked expanses of the deserts, and finally back again as you neared another distant sea. It was a single world, but it contained within itself climates and landscapes that today would be separated by entire oceans. This was the true scale of Pangea, a land so vast that it carried its own extremes within its borders. And yet, despite these differences, this single supercontinent was never a static or finished creation. Its mountains continued to shift, its climate kept evolving, its deserts grew and shrank, while its coastal regions changed with the rise and fall of ancient seas. It was a world in constant motion, and that motion was far from over. The deeper you ventured into Pangea's heart, the farther you left the ocean's life-giving influence behind. Moisture from the coast couldn't reach these depths. Winds lost their strength, and the air grew bone-dry under an endless, merciless sky. This was the great interior, a land defined not by what it possessed, but by what it completely lacked. Here rain was a rare and precious visitor. Months could pass without a single storm cloud appearing on the horizon, and when clouds finally gathered, their showers would vanish almost as quickly as they arrived, swallowed greedily by the parched ground below. This interior was absolutely vast, stretching for thousands of kilometers in every direction. Modern deserts like the Sahara or Gobi may seem enormous, but they're small compared to the dry wastelands that dominated Pangea's center. Geologists studying ancient rocks have uncovered layer after layer of red sandstone, iron-stained and baked by relentless heat. This is proof of an arid world that endured for millions of years. These layers reveal a landscape sculpted entirely by sun and wind, where rivers were few and lakes were temporary, vanishing whenever the brief rains faded away. The climate here was harsh and absolutely unrelenting. During the day, the sun beat down without any mercy. Without clouds to soften its glare, the ground would heat until the air shimmered with waves of rising heat. At night, temperatures dropped sharply with no moisture to hold on to the warmth. The land cooled rapidly, leaving the air cold and thin under a brilliant dome of stars. Life in this environment had to bend completely to its rules or vanish entirely. Plants in this interior were sparse, but they were far from absent. Low, incredibly hardy vegetation clung desperately to the soil. Early conifers, seed ferns, and other drought-resistant species adapted to the constant struggle for water. Their roots reached deep underground, searching desperately for moisture trapped far below the surface. Between these isolated pockets of green stretched wide plains of dry earth and rock, interrupted only by scattered dunes and the faint traces of ancient riverbeds. These rivers, when they flowed at all, often ran only briefly before fading into the ground or evaporating under the relentless sun. Animals that dared venture here carried the same marks of extreme adaptation. Many were small, their bodies built to lose minimal water. Some burrowed deep underground, escaping the daytime heat and emerging only when the sun dipped low on the horizon. Others moved cautiously along the edges of the few surviving rivers, living on whatever water and vegetation they could find. Early mammal-like reptiles left their tracks in this unforgiving land alongside the footprints of smaller predators and the occasional larger herbivore that followed seasonal shifts in desperate search of better grazing grounds. The wind was a constant companion in this great interior. With no forests to break its flow, it swept endlessly across the open land, carrying dust from one horizon to the next. Over millions of years, this dust left its permanent mark, settling in layers that still remain locked in the rock record today. It would have been a world of muted colors, reds and browns baked by the sun, pale skies that shifted from dazzling blue to deep, star-strewn black, and little else to break the monotony except the jagged outlines of distant mountains on the far horizon. Yet this harshness wasn't complete lifelessness. Even in this dry core of Pangea, ecosystems somehow endured. Small oases existed where underground springs surfaced like miracles in the wasteland. Seasonal floods from distant mountains carved temporary rivers through the parched land, drawing life from every direction like magnets. Fossils from these areas reveal sudden bursts of activity, evidence that for brief, precious moments these arid regions exploded into life when water returned. only to fall silent again when the heat inevitably reclaimed them. The sheer size of this interior created an even more profound challenge: complete isolation for the animals and plants trapped in Pangea's heart. The distances were absolutely staggering. Migration from one fertile region to another could literally take generations of animals to complete. Populations became increasingly specialized, molded relentlessly by the demands of the dry environment until they no longer resembled their relatives from the distant coastal forests. This slow process of adaptation became one of evolution's greatest engines within Pangea's interior, producing species that could endure conditions few other creatures could survive. It was like a massive biological laboratory where only the most resilient traits would be passed down through countless generations. The wind-driven climate also reshaped the land itself over vast stretches of time. Without heavy rainfall to speed erosion, rocky outcrops that formed during Pangea's violent creation remained exposed for millions of years, their surfaces scoured smooth but never completely erased. Sand carried by constant gusts sculpted massive dunes and carved intricate patterns into solid stone. These marks of ancient weather remain perfectly preserved in the rocks we study today, serving as silent witnesses to a world where the desert truly seemed endless. Despite its brutal severity, this great interior was deeply connected to the rest of Pangea through invisible threads. Dust from these dry lands drifted outward constantly, carried by relentless winds into the wetter regions near the coasts, feeding distant forests with precious minerals. Seasonal storms, though incredibly rare, sometimes formed along the interior's edges and swept outward, pushing waves of dry air into greener lands and shifting weather patterns far beyond the desert's apparent reach. In its own mysterious way, this seemingly empty expanse influenced the entire supercontinent, tying the fate of its barren interior to its life-giving coasts. To travel through Pangea's heart would have been to experience silence on a scale almost unknown today. No sound of crashing waves, no dense canopy of leaves rustling in humid breezes. Only the endless sweep of air across ancient stone and the occasional cry of an animal, perfectly adapted to the emptiness. And yet this silence wasn't empty of meaning. It was here in this great arid core that life learned to endure its harshest tests, preparing for the evolutionary challenges that lay ahead in the changing world to come. While Pangea's heart was dominated by scorching winds and empty horizons, its edges were shaped by an entirely different force: the surrounding ocean. Panthalassa, the vast global sea that wrapped around the supercontinent, stretched outward in every direction, so immense that even from Pangea's coasts it would have seemed truly endless. This single ocean wasn't merely a backdrop. It was one of the most powerful influences on the climate, ecosystems, and movement of life across the entire planet. Where land met sea, the world was completely transformed. Moisture carried inland by ocean winds fed the coastal regions generously, creating belts of life far greener than the barren interior could ever support. These coastal areas were home to rivers swollen by seasonal rains, wetlands teeming with primitive amphibians, and forests so dense they formed nearly unbroken canopies, stretching for hundreds of kilometers. It was along these life-giving shores that existence thrived most abundantly, sustained by the constant interaction between land and water in perfect balance. The ocean itself was no less extraordinary than the land it bordered. Panthalassa covered nearly 3/4 of the planet, its deep currents circulating slowly but with immense planet-wide reach. With only one massive continent to disrupt its flow, its waters moved around Pangea in vast loops, distributing heat from the equator toward the poles like a planetary heating system. This steady circulation helped regulate the climate of the coasts while leaving the interior lands to their brutal extremes. Near the shorelines, Pantalassa's influence was immediate and dramatically visible. Warm, shallow seas flooded low-lying regions along the continental margins, creating aquatic wonderlands. These shallow zones, sometimes stretching for hundreds of kilometers, were absolutely ideal for life to flourish. Ancient reefs built by early corals and sponges rose majestically from the seabed. Schools of primitive fish swam through crystal-clear waters while trilobite-like arthropods, though nearing the end of their evolutionary reign, still clung desperately to survival in isolated pockets. In these coastal waters, nutrient cycles created vital connections between land and sea. Rivers from the interior carried sediments rich with minerals, feeding the shallow marine ecosystems like liquid fertilizer. These nutrients fueled massive blooms of plankton, which in turn supported a growing web of marine life. Fossils from these ancient seabeds tell incredible stories of abundance. Fish of countless forms, invertebrates with strange ornate shells, and predators that patrolled these waters long before the first dinosaurs ever walked on land. The coasts were also shaped by the ocean's changing moods. Seasonal monsoons driven by Pangea's immense size brought powerful storms to its edges with devastating force. These rains replenished the rivers and wetlands, but they also brought catastrophic flooding, reshaping the landscape year after year. In some regions, these storms carried salt-laden air far inland, leaving behind crusted flats where water evaporated faster than it could collect. Each cycle carved another permanent mark into the land, building a coastline that remained in constant motion. Despite the challenges of its interior wasteland, Pangea's coasts were places of incredible connection. They linked the land to the ocean and acted as crucial gateways for life between these two vastly different worlds. Amphibians ventured into the wetlands to lay their eggs, relying on the steady flow of fresh water for survival. Vipitioles followed, evolving revolutionary traits that freed them from dependence on aquatic breeding, giving them the ability to move farther inland than ever before. Even the first primitive ancestors of mammals likely emerged near these coasts, their survival intimately tied to the rich ecosystems that stretched between sea and land. The air along these edges would have been thick with life and constant activity. Insects buzzed endlessly through forests that bordered tidal flats. Early reptiles basked contentedly on sun-warmed rocks beside shallow lagoons. Primitive ferns and seed plants flourished in the humid climate, their roots gripping the nutrient-rich soil washed down from distant highlands. Every part of the coast was alive with movement, and every season brought new growth, new migrations, and new struggles for survival. But just as the ocean gave life abundantly, it also drew clear lines of contrast. While the coasts were lush and dynamic, just a few hundred kilometers inland, the greenery would gradually fade away. Rainfall diminished dramatically, and the air grew increasingly dry. The ocean's reach was incredibly powerful, but it wasn't limitless. This sharp gradient between fertile coastal zones and the arid interior was one of Pangea's most defining features, a transition so dramatic it created entirely different worlds within the same continent. This served as a powerful reminder that even on a world of completely connected land, the edges and center operated by vastly different rules. The ocean itself, though appearing constant from the shore, was anything but still. Its relentless tides and currents shaped erosion patterns along Pangea's coastlines, carving into towering cliffs and depositing sediments in entirely new locations. Some regions remained drowned beneath shallow seas for millions of years before the water finally retreated. Others rose dramatically upward as Earth's crust shifted, exposing once submerged seafloors to open air for the first time in eons. This constant exchange between land and sea created a shifting map that forced life to adapt continuously, again and again, and Pantalasa wasn't alone in shaping this world. Along Pangea's eastern edge lay the Paleotethys Sea, a smaller but equally crucial body of water that told its own story. It was here, in this relatively sheltered sea, that countless early marine species discovered stable habitats away from the chaos of the open ocean. Shallow waters protected by extensive continental shelves became evolutionary cradles, nurturing incredible diversity among creatures that would later spread throughout the larger ocean. This sea served as a peaceful counterpoint to Pantalasa's deep, open expanse, offering quiet refuge while the rest of the planet's waters churned in their vast, uninterrupted circulation patterns. Standing on Pangea's coastline, you would have witnessed an alien sight: no distant islands breaking the horizon, no neighboring continents rising mysteriously from the waves. Only the open ocean stretched endlessly to every horizon, creating a blue void that completely surrounded Earth's one connected landmass. The rhythmic sound of waves crashing against ancient shores, the haunting cries of primitive reptiles echoing from nearby forests, and the steady winds sweeping inland would have been constant reminders that this world was vast, unbroken, and still in perpetual motion. These oceans at the edge of everything weren't simply boundaries. They were the living, breathing skin of the planet, binding water, air, and land into one unified system that set the rhythm for all life on Earth. And from these dynamic coasts, Pangea's story would continue inward once again, into the forests and plains that stretched between sea and desert, where the planet's strange and evolving life would take its next crucial evolutionary steps. The very air of Pangea wasn't the same atmosphere we know today. It was thicker during some ages, dramatically thinner in others, and its unique composition left permanent marks on every creature and plant that inhabited this world. To step outside and take a breath during this ancient time would have been to inhale an atmosphere shaped by a planet in complete transition, one that carried both the massive weight of its geological past and the unlimited potential for everything still to come. Evidence locked deep within rock layers reveals that oxygen levels during parts of Pangea's existence were significantly higher than what we breathe now. In the late Carboniferous period, just before Pangea reached its full magnificent form, oxygen may have comprised as much as 35% of the atmosphere, compared to today's 21%. That extra oxygen changed absolutely everything about life on Earth. It fueled the explosive growth of enormous insects and arthropods, creatures that depended entirely on simple diffusion to deliver oxygen throughout their bodies. Dragonflies with wingspans longer than a human arm soared majestically over dense forests. Millipede-like invertebrates grew to lengths that would be absolutely startling in any modern landscape. The air quite literally allowed them to become giants beyond our imagination. Yet the atmosphere never remained constant. As Pangea stabilized and entered the Permian period, oxygen levels began their dramatic decline. By the middle of that era, they may have dropped to around 15%, a level that would leave modern humans gasping for breath. But the animals of that time had evolved perfectly for these conditions. Their lungs and circulatory systems developed to extract every precious bit of oxygen they needed from the thinning air. This atmospheric shift completely reshaped ecosystems, favoring species that could endure lower oxygen levels while gradually pushing the oversized insects of earlier ages into evolutionary decline. Carbon dioxide also played its crucial part in this atmospheric drama. Volcanic eruptions along Pangea's fault lines released enormous amounts of it into the atmosphere, warming the planet and fueling incredibly powerful weather systems. This greenhouse effect helped maintain the coastal forest's humid, lush conditions, while in the great interior, the intense heat only deepened the crushing aridity. The very chemistry of the air was intimately tied to the geology of the supercontinent. Each eruption, each tectonic shift influenced life in ways that could still be measured today in the fossilized bones of animals that managed to survive. For plants, this unique atmosphere was simultaneously a challenge and an unprecedented opportunity. High levels of carbon dioxide strongly favored the growth of massive forests. Seed ferns, towering conifers and other ancient plants absolutely thrived, their leaves constantly pulling in the gas and releasing oxygen in return. These forests became vast oxygen factories, feeding the planet's atmosphere while anchoring the entire climate system. When they spread along river valleys and coastal lands, they created pockets of breathable abundance in a world otherwise dominated by brutal extremes. But the connection between air and life ran even deeper than basic respiration. Atmospheric circulation, the movement of air around Pangea, was unlike anything on Earth today. With nearly all land gathered into one massive block, wind patterns became larger and simpler, moving completely unimpeded across thousands of kilometers. Warm air rose powerfully above the equator, driving intense monsoons along the coasts, while cooler, bone-dry air descended into the interior, feeding the vast deserts that sprawled across Pangea's heart. The atmosphere itself became a massive engine, and every living thing existed within its powerful currents. Even the color of the sky may have appeared subtly different from our modern view. Higher concentrations of volcanic aerosols during periods of intense eruptions would have filled the air with countless fine particles, scattering sunlight and tinting the horizon in unusual hues. Some sunsets might have burned with deep red intensity, their glow carrying across the flat open lands of the interior for hundreds of kilometers. At other times, when the air finally cleared, the sky would have stretched in an unbroken blue arc, vast and sharp, with little moisture to soften its appearance. The very breath of Pangea also carried intense heat across its surface. Without the moderating influence of multiple smaller continents and oceans, seasonal temperature swings became far more extreme than anything we experience today. Summers in the interior baked relentlessly under scorching, dry air, while winters cooled dramatically, the air turning thin and biting. The coastal regions remained gentler, their atmosphere tempered by constant ocean breezes, but even there the rhythms of the supercontinent could always be felt. When monsoon season finally arrived, humid winds swept powerfully to shore, feeding the forests with warm, moisture-laden air. When those winds shifted away, dry air immediately reclaimed the land. And in this unique atmosphere, every animal lived in perfect lockstep with the air they breathed, their entire existence shaped by the chemical composition of this ancient world. Some species evolved incredibly efficient lungs designed to extract every molecule of oxygen from the increasingly thin atmosphere. Others became absolute masters of stillness, conserving precious energy, heat, and moisture in their bodies like living batteries. Plants made remarkable adjustments to their leaf structures, with specialized pores that opened and closed strategically to preserve water while still absorbing the gases they desperately needed to survive and grow. Every single adaptation was a direct response to the changing air around them, and every shift in atmospheric composition sent ripples cascading through the entire web of life like dominoes falling across a continent. But perhaps the most striking aspect of Pangea's atmosphere wasn't just its unique chemistry, it was its incredible unifying reach. One single atmosphere enveloped every corner of this massive supercontinent. Winds that originated in the scorching deserts of the interior could sweep dramatically out to the distant coasts, carrying precious dust and minerals that would eventually settle into soils thousands of kilometers away. Moisture from the surrounding oceans could drift steadily inland until it gradually faded and fell as life-giving rain. This atmospheric circulation connected the harsh deserts to the lush forests, the towering mountains to the endless plains, and every living creature to every other in an invisible web of shared air. To stand anywhere on Pangea and take a breath would have been to inhale that entire world at once, the bone-dry heat of its interior wasteland, the salt-tinged winds from its coastal regions, and the faint traces of volcanic gases carried from distant eruptions. Every breath served as a powerful reminder that on this unified continent, air wasn't divided or contained by barriers. It was the common thread that linked one end of the world to the other in perfect unity. And as the atmosphere continuously shaped life, life in turn reshaped the atmosphere, creating a feedback loop that would define this entire era and prepare our planet for the dramatic changes ahead. Within Pangea's air, heavy with geological history and restless with constant motion, lay the seeds of everything that would follow. The world of Pangea was now preparing for its next great transformation. Its unique atmosphere, vast deserts, dynamic coasts, and dense forests had already set the stage perfectly, and now life itself was beginning to respond in revolutionary ways. This was the crucial age before the dinosaurs, an era when the ancestors of future giants were taking their very first evolutionary steps. Earth wasn't yet ruled by the towering creatures that would dominate later periods, but the foundations for their spectacular reign were being laid quietly, carefully, one adaptation at a time. During the late Carboniferous period and into the Permian era, life on land became dramatically more specialized than ever before. The forests near the coasts were dense, incredibly humid, and filled with fierce competition for resources. Here amphibians still dominated the rivers and swamps, their entire existence tied closely to water sources for survival. But among them were exciting new arrivals, reptiles. These were creatures that carried a truly revolutionary advantage, the amniotic egg. Unlike their amphibian cousins, reptiles no longer needed to return to water bodies to reproduce successfully. Their eggs, brilliantly protected by tough shells and specialized membranes, could survive and develop on completely dry land. This single, game-changing adaptation opened the door wide to Pangea's interior, to the harsh deserts and dry plains that amphibians simply could not reach or colonize. These pioneering reptiles weren't yet the massive predators or towering herbivores of later geological ages. Many remained small, incredibly quick, and stayed low to the ground, feeding primarily on insects and other small prey. But some began growing significantly larger, testing new evolutionary possibilities. Among the most fascinating were the synapsids, a diverse group of creatures that would eventually give rise to all mammals. During the Permian period, however, They were actually the dominant land animals across Pangea, and their forms were as strange as they were varied. Some, like the iconic Dimetrodon, carried enormous sail-like structures on their backs, possibly for regulating body temperature or creating impressive displays during mating seasons. Others possessed incredibly powerful jaws and sturdy bodies built specifically for endurance, roaming the drier regions of the supercontinent in relentless search of prey. In the coastal forests and along riverbanks, massive herbivorous synapsids browsed peacefully on ferns and seed plants, their specialized teeth perfectly adapted for grinding tough vegetation into digestible matter. These were stocky, slow-moving animals, but their impressive size offered crucial protection in this dangerous world. In Pangea's landscape of vast distances and harsh climatic extremes, being large became a significant evolutionary advantage. Size allowed these creatures to travel much farther in search of food sources, endure longer periods without water, and survive the dramatic seasonal swings that characterized Pangea's climate patterns. The insects of this remarkable age remained extraordinary in their own right. With oxygen levels still elevated from earlier periods in Pangea's history, some had reached sizes that would seem absolutely impossible today. Dragonflies with wings stretching nearly a full meter across glided majestically over ancient rivers and wetlands. Millipede-like arthropods extended several feet in length, crawling deliberately across forest floors like living trains. Although their dominance was gradually declining as atmospheric oxygen levels dropped, they remained a defining feature of Pangea's landscapes, living reminders of an age when the air itself had allowed life to grow to truly astonishing proportions. In the vast ocean surrounding Pangea, marine life was equally dynamic and diverse. Large predatory fish armored with thick protective scales hunted efficiently in the open waters. In the shallower coastal regions, early sharks prowled with sleek efficiency, their evolutionary lineage already well established along coastlines and in smaller inland seas. Countless invertebrates like brachiopods, ammonites, and crinoids populated the seafloor, constantly filtering nutrients carried by Panthalassa's powerful currents. These oceans were vast and incredibly deep, but they remained intimately connected to the rhythms of the land above. Dust from Pangea's interior deserts regularly carried essential nutrients into the sea, while seasonal floods from coastal rivers continuously replenished the continental shelves with minerals that sustained thriving marine ecosystems in perfect balance. Back on land, evolution's first great experiments with massive size were beginning to appear across the supercontinent. Among the synapsids and early reptiles were forms that clearly hinted at what was coming in future ages. Some grew significantly heavier and more imposing, testing the absolute limits of what the land could physically support. Their fossilized skeletons, preserved perfectly in stone, reveal sturdy limbs specifically built to carry tremendous bulk and specialized teeth designed to handle an incredible range of different diets. These weren't yet the colossal giants of the later Triassic and Jurassic periods, but they were definitely their evolutionary precursors, life's first ambitious attempts at filling Pangea's enormous spaces with equally enormous creatures. The supercontinent's unique climate actively drove this evolutionary process forward at an accelerated pace. In the lush coastal regions, food sources were incredibly abundant year-round. Forests produced layer upon layer of nutritious vegetation, and herbivores could feed almost continuously without major challenges. In the arid interior, by dramatic contrast, survival strongly favored endurance and substantial size. Larger animals could travel much farther distances to locate water sources and store energy more efficiently in their bodies. Over millions of years, these environmental pressures systematically shaped the bodies of creatures living there, perfectly setting the stage for the rise of the truly great evolutionary lineages to come. Predators inevitably followed this trend. As herbivores grew progressively larger and more powerful, the hunters that preyed on them also evolved to match their quarry in raw strength, speed, and hunting efficiency. Early reptilian predators developed longer jaws packed with razor-sharp teeth, evolving specifically to take down these increasingly formidable prey animals. These evolutionary arms races of size and raw power would ultimately continue into the Triassic period, where they would eventually give birth to the first true giants of the Mesozoic, the legendary age of the dinosaurs. But even in this earlier time, the pattern was already crystal clear. Pangea had become a world that richly rewarded adaptation on the most grand scale imaginable. The supercontinent's incredible interconnectedness accelerated this process dramatically. With no vast oceans to block their migration paths, species could spread across absolutely enormous distances, carrying revolutionary new traits from one region to another like biological messengers. A predator that first evolved in one remote corner of Pangea could, over geological time, follow its prey into entirely different climates and ecosystems. Herbivores could migrate freely from the lush, wetter coastlines to the harsh, drier interior, their populations branching and adapting brilliantly to the unique conditions of each new region they encountered. Evolution didn't happen in isolation here. It unfolded on a truly continental stage where every movement of wind, every seasonal shift, and every geological change sent ripples through that immense connected system. And while the colossal giants of the future hadn't yet arrived to dominate the landscape, all the groundwork was perfectly set. The forests were spreading like green waves across the land. The deserts were waiting patiently in the interior. The atmosphere was changing in profound ways, and in the quiet spaces between survival and adaptation, life was preparing to grow larger, stronger, and stranger than ever before in Earth's history. Across Pangea's vast stretches, the forests were completely unlike anything we know today. They were older, stranger, and built from forms of life that have long since vanished from our planet forever. These ancient woodlands served as the lungs of the supercontinent, actively shaping the atmosphere, anchoring precious soil, and providing essential shelter for the growing diversity of animals that roamed the land. To walk beneath their towering canopy would have been to step into a world both alien and hauntingly familiar, a place where evolution was still actively experimenting with the fundamental building blocks of future ecosystems. In the humid belts near the life-giving coasts, the forests were dense and absolutely towering. Massive seed ferns with fronds as broad as a human's outstretched arms formed thickets so incredibly thick that little sunlight could penetrate to the ground below. These remarkable plants, neither true ferns nor flowering trees, dominated enormous areas of Pangea's landscape with their unique forms. Their sturdy stems and broad leaves built sprawling networks of shade beneath which smaller plants fought desperately for every precious sliver of light that filtered down. In this dim green world, the air hung heavy with constant moisture, and the ground was layered with thick mats of decaying vegetation that would eventually become the coal seams now buried deep beneath our modern continents. Towering majestically above the seed ferns were the early conifers, the direct ancestors of today's pines, firs, and spruces. But during the Permian and Triassic periods, they were pioneering giants unlike anything we see now. Their needle-like leaves allowed them to survive successfully in a much wider range of climates, from the waterlogged coastal lands to the drier uplands that bordered Pangea's harsh interior. Their wood, strong and richly resinous, supported massive trunks that reached skyward like ancient skyscrapers, creating distinct vertical layers within the forest ecosystem. Among these towering branches, small reptiles and early insects found crucial refuge, their movements completely hidden beneath the dense evergreen canopy. Closer to the interior regions, where the climate grew increasingly harsher and rainfall became desperately scarce, the lush forests gradually thinned into something entirely different. Here, drought-tolerant plants dominated the landscape. Hardy conifers, low-growing shrubs, and cycads with stiff, leathery leaves that could withstand brutal conditions. These cycads, with their strange crown-like tops of fronds, seemed like living relics from an even older time. They thrived in places where few other plants could even take root, anchoring the precious soil and feeding the brave herbivores that ventured into the dry lands between the forests and Pangea's great central deserts. In some regions, especially near the coasts and river valleys, dense forests merged seamlessly with vast wetlands to create unique ecosystems. These swampy environments were dominated by ancient horsetails and club mosses, plants that once reached heights far greater than their tiny modern descendants could ever achieve. Their hollow, jointed stems formed dense stands along water's edge, their extensive root systems binding the soil against shifting currents and seasonal flooding. These wetlands became crucial nurseries of life, sheltering amphibians that still needed water to breed successfully, while early reptiles patrolled the edges constantly in search of unsuspecting prey. The forests of Pangea were anything but silent. Insects filled the air with a constant rhythmic hum, their wings flashing brilliantly in the dappled sunlight that filtered through the canopy. giant dragonflies, their wings beating slowly and deliberately, skimmed gracefully above clearings and riverbanks like prehistoric helicopters. On the forest floor below, massive millipede-like arthropods crept methodically through thick layers of leaf litter, while beetles and early ants began their crucial work of breaking down decaying plant matter into rich soil. Every sound and movement in these ancient forests was part of an incredibly intricate web that tied the entire ecosystem together in perfect balance. And where plant life existed in such abundance, herbivores inevitably followed in great numbers. Early synapsids and reptiles browsed peacefully among the ferns and cycads, their specialized jaws perfectly adapted to grind through the toughest fibrous vegetation. Some carried squat, barrel-shaped bodies specifically designed to house powerful digestive systems capable of extracting every bit of energy from Pangea's tough forest plants. Their fossilized tracks, beautifully preserved in stone, crisscross ancient floodplains that were once shaded by towering trees now long extinct. Even fierce predators depended heavily on these forests, though not directly for food. The dense vegetation provided perfect cover for ambush hunters who relied on stealth and surprise. Smaller reptiles and early carnivorous synapsids stalked silently through the shadows, their deadly movements completely hidden by the multiple layers of plants above. The forest served as both sanctuary and hunting ground, a place where every leaf, branch, and shadow played a crucial role in the eternal struggle for survival. The air inside these forests would have felt dramatically different from the scorching dry winds of the interior deserts. Humid and heavy, it carried the rich scent of pine resin, wet soil, and constantly decaying plant matter. Sunlight broke through the canopy in narrow golden shafts, striking the forest floor in fleeting patches that danced with the movement of leaves above. In the coastal lowlands, fog sometimes rolled mysteriously in from the ocean, wrapping the ancient trees in a pale mist that lingered until the intense heat of the day finally burned it away. Farther north and south, where the climate gradually cooled, the forest transformed once again. Conifers became increasingly dominant, their evergreen needles perfectly adapted to survive in regions where winters could bring killing frost. These forests were sparser than their lush equatorial counterparts, but they were incredibly resilient, holding their ground stubbornly even as the seasons turned harsh and unforgiving. All across Pangea, the forests connected the land like a vast green network. They followed the winding rivers deep into the interior, stretched along the entire coastline, and climbed the foothills of mountain ranges born from the continent's great collisions. They weren't a single unbroken expanse, but rather a complex network of green that bound the supercontinent together, constantly feeding its atmosphere with precious oxygen and actively shaping the evolution of its creatures. In time, these magnificent forests would also become the stage for the next great transformation. As global climate shifted and Earth's atmosphere changed in profound ways, the plants that had ruled Pangea for millions of years would face entirely new competition that would reshape the world once again. But in this pivotal moment, during the absolute height of the supercontinent's golden age, these forests reached their magnificent peak, vast, completely untamed, and serving as home to the very first foundations of the world that was still waiting to emerge from the mists of time. Life on Pangea wasn't only written in the towering forests and endless deserts, it was also carved into the very essence of the creatures that moved across these ancient landscapes like living brushstrokes on a planetary canvas. The supercontinent had become home to an absolutely extraordinary array of animals, from the tiniest crawling insects to the first truly powerful reptiles that would eventually dominate the land with iron fists. Each of these creatures was part of an unfolding epic of survival and adaptation, their every characteristic shaped by the climate's demands, the atmosphere's composition, and the boundless connected geography that made Pangea unlike any world before or since. In the humid lowlands and lush coastal forests, insects ruled both the undergrowth and the air above it with absolute authority. Oxygen levels in earlier geological ages had fueled their explosive expansion into forms far larger than almost any modern species could ever achieve. Dragonflies with wingspans stretching close to a full meter soared majestically between the ancient trees, their massive compound eyes locked onto prey that they captured with swift, precise movements that would make modern predators jealous. Their flight was steady and incredibly powerful, a living testament to how dramatically Pangea's unique atmosphere had enabled these early aerial hunters to achieve sizes that seem impossible today. On the forest floor below, giant millipede-like arthropods crept methodically through the damp litter of constantly decaying plants, their movements creating a rustling symphony in the shadows. Some of these incredible creatures stretched several feet in length, their countless legs rippling in mesmerizing waves as they moved slowly across the shadowed forest floor like living trains. They were dedicated detritivores, constantly consuming fallen leaves and rotting wood, playing an absolutely vital role in recycling precious nutrients back into the rich soil that fed the entire ecosystem. Alongside them, massive beetles, primitive cockroaches, and early relatives of modern ants and termites formed bustling micro-ecosystems in the dark spaces hidden beneath the towering canopy. These insects weren't simply background life filling empty spaces. They were the fundamental foundation of Pangea's entire terrestrial ecosystem. They fed voraciously on plants, broke down organic waste with incredible efficiency, and in turn became essential food sources for the first small reptiles that had finally left the swamps behind forever. This was truly a world caught in the middle of a revolutionary transition, where amphibians still lingered desperately near rivers and wetlands, clinging to their aquatic heritage. But reptiles were beginning to step boldly farther inland, no longer chained to water sources for reproduction thanks to their revolutionary adaptation. Their eggs, encased in tough protective shells, had become the key to their complete independence from aquatic environments, a game-changing evolutionary breakthrough. Among these pioneering reptiles were early synapsids and diapsids, two crucially important groups that would eventually give rise to turtles, lizards, snakes, crocodiles, and even the mighty dinosaurs themselves. But during Pangea's age, they remained small, cautious creatures testing the boundaries of their new terrestrial world. They hunted insects skillfully among the massive roots of towering seed ferns or basked contentedly in precious patches of sunlight that managed to break through the dense forest canopy above. Their limbs were remarkably strong, their bodies low and perfectly agile, brilliantly suited for navigating the dense vegetation and uneven ground of this ancient world that bore no resemblance to anything we know today. The synapsids, the group that would ultimately give rise to all mammals, including us, were also thriving in spectacular fashion across Pangea's diverse landscapes. Some were small insectivores, quick and sharp-eyed, darting like shadows between hiding places in their relentless search for prey. Others, like the early herbivorous cynodonts, carried distinctive barrel-shaped bodies and incredibly strong jaws. They used their impressive size as both defense against predators and as a powerful tool for processing the fibrous plants that grew in spectacular abundance across Pangea's connected landscapes. They shared these ancient forests with amphibians that had adapted remarkably to life on land but still returned faithfully to water to breed, desperately clinging to the last remnants of a much older age. In the wetlands and along the winding rivers, amphibians remained the dominant vertebrates, ruling their watery kingdoms with absolute authority. Some were small and incredibly nimble, their slick skin allowing them to breathe efficiently both in water and on land. Others were massive, crocodile-like predators with terrifyingly wide jaws and razor-sharp teeth, waiting motionlessly beneath the surface for an unwary fish or reptile to venture too close to their hidden ambush. These amphibians were living relics of an earlier world, but in the rich, waterlogged environments of Pangea's life-giving coasts, they continued to hold their ground stubbornly for millions of years, refusing to surrender to the advancing reptilian revolution. The complex interactions between these groups, amphibians, reptiles, synapsids, and insects, created an incredibly intricate web of life that connected every corner of the supercontinent. In the coastal forests, insectivorous reptiles relied completely on the dense insect populations for survival, while amphibians preyed efficiently on fish and smaller creatures in the swamps. Larger synapsid predators began testing their growing strength against the other inhabitants of this interconnected world, establishing new hierarchies of power. Fossil trackways preserved perfectly in the rocks of ancient floodplains capture these dramatic moments frozen in time. The prints of small reptiles zigzagging frantically between the massive marks left by lumbering herbivores, with the faint but ominous impressions of predators trailing silently behind. Farther inland, in the increasingly drier zones of Pangea's interior, reptiles became the true pioneers of terrestrial life. Unlike their amphibian cousins, they didn't need standing water to survive. and they followed the meandering rivers and sparse vegetation deep into the continent's harsh interior regions. Here they evolved tougher, more protective skin to conserve precious moisture, stronger limbs capable of traveling over open ground for vast distances, and behaviors perfectly suited to a much harsher climate than their ancestors had ever known. These inland reptiles represent one of the earliest examples of life fully adapting to the arid heart of Pangea, where rain was desperately scarce and the sun was absolutely unrelenting. The insects followed them even into these harsh environments, proving life's incredible adaptability. Hardy species capable of withstanding extreme heat and prolonged drought spread courageously across the drylands like biological pioneers. Termite-like insects may have begun forming the first colonies, burrowing deep into soil and wood to build protected environments against the scorching sun. In turn, the reptiles and early synapsids that hunted them adapted alongside their prey in an endless evolutionary dance, their movements shaped by the constantly shifting balance between predator and food source. The forests, swamps, and deserts of Pangea were thus bound together not only by the land itself, but by the constant flowing movement of life across its vast expanse. Every plant fed an insect with its leaves or nectar, every insect became food for a reptile, and every predator carved its unique niche in a landscape so incredibly vast that no single ecosystem could stand alone. The absence of dividing oceans between these habitats meant that animals and plants could spread far more easily than they can in today's fragmented world, turning Pangea into one single interconnected stage where evolution played out its greatest experiments on a truly continental scale. In this remarkable world, every creature was part of a grand experiment in the possibilities of life. The insects that grew massive in the oxygen-rich air, the reptiles that finally shed their evolutionary ties to water, and the synapsids that prowled the shadows were all essential pieces of a complex puzzle that would eventually give rise to Earth's future rulers. But for now, they were simply survivors of a world still desperately finding its balance. A world where the land existed as one unified whole, the air hung heavy with possibility, and life was beginning to take its next truly great leap forward into an uncertain but exciting future. As life spread triumphantly across Pangea's vast expanse, one particular lineage of creatures began taking on shapes and traits that would eventually lead directly to us. These were the synapsids, sometimes called mammal-like reptiles, though in truth they were neither fully reptile nor fully mammal. They existed in that fascinating evolutionary space between categories. They were a transitional group, serving as a crucial bridge between the cold-blooded hunters of the ancient past and the warm-blooded animals that would one day rise to dominate the entire Earth. In the late Permian period, the synapsids had already become among the most successful animals on land, proving their evolutionary superiority. They came in an incredible variety of forms, from small, sharp-toothed insect hunters that darted through undergrowth to massive, heavy-bodied herbivores that could easily rival the size of a modern rhinoceros. Their most distinctive and identifying feature was a single temporal opening behind each eye in their skull, a characteristic that would define their lineage and separate them from all other reptilian groups forever. This seemingly minor evolutionary change provided their jaw muscles with crucial room to expand and develop. This apparently small difference gave them dramatically stronger bites, lightning-fast strikes, and far more efficient feeding capabilities than many of their reptilian competitors could ever achieve. A game-changing advantage in the brutal world of Pangea. One of the most famous and iconic early synapsids was Dimetrodon, a creature that looked like it had been pulled straight from the realm of science fiction. With its long, sprawling body and the enormous sail rising majestically from its back, it appeared almost mythical against Pangea's ancient landscapes. That distinctive sail wasn't merely for intimidating display, it likely served as a sophisticated biological thermostat. This remarkable adaptation may have helped regulate body temperature with incredible precision, capturing precious heat during cool mornings and releasing excess warmth during the scorching hours of midday. In Pangea's unpredictable and often brutal climate, such an evolutionary innovation could literally mean the difference between survival and extinction. But not every synapsid was a fearsome predator stalking through the shadows. The herbivorous forms like Edaphosaurus carried smaller but equally important sails and possessed wide, blunt teeth specifically designed for grinding the toughest plant materials. These gentle giants moved slowly but deliberately across Pangea's floodplains and forests, feeding peacefully on cycads, ferns, and other hardy vegetation that could survive in harsh conditions. Their massive bodies were built for endurance rather than speed, and their impressive size served as effective deterrent against smaller carnivores that prowled constantly in their shadows, looking for easy meals. As the Permian period progressed and evolved, other synapsids emerged that pushed significantly closer to what we would recognize as truly mammal-like characteristics. The therapsids, for instance, began displaying increasingly advanced traits that set them apart from their predecessors. They developed stronger limbs held more vertically beneath their bodies, differentiated teeth perfectly designed for slicing and chewing, and perhaps even early signs of whiskers or hair-like structures, though direct fossil evidence of this remains hotly debated among paleontologists. These revolutionary features gave them an undeniable evolutionary edge. They became faster, more efficient, and better suited to handle the incredibly varied climates that characterized Pangea's vast expanse. Among the therapsids were formidable predators like the gorgonopsids, sleek, muscular hunters equipped with long, saber-like teeth that could slice through flesh with devastating efficiency. They ranked among the apex predators of their time, stalking relentlessly across the dry interior plains and river valleys of the supercontinent. Their skulls were significantly more advanced than those of earlier synapsids, clearly hinting at a major shift toward quicker reflexes and dramatically sharper senses. In a world as vast and completely open as Pangea, these adaptations allowed them to chase prey across incredible distances and seize any opportunity to strike with deadly precision. Yet alongside these fearsome predators thrived herbivorous therapsids like the remarkable Dischetodonts. These stocky, tusked creatures possessed distinctive beak-like mouths, perfectly designed for clipping vegetation, and incredibly powerful jaws capable of grinding down the toughest plant materials. Fascinating fossil evidence suggests that some Dischetodonts may have traveled in massive herds, moving together across the landscape in coordinated searches for food sources. Their remarkable ability to survive in both the wetter coastal regions and the bone-dry interior helped them spread across nearly every corner of Pangea, leaving their fossilized remains on continents that today lie separated by entire oceans. What made these mammal-like creatures truly remarkable was their incredible versatility and adaptability. They weren't tied to one specific environment or limited to one way of life. Some thrived magnificently in the humid forests along the life-giving coasts, where plants grew in abundance and fresh water was easy to find. Others adapted brilliantly to the arid heart of Pangea, learning to conserve energy and endure long stretches without any moisture whatsoever. Their geographic range was so absolutely vast that they became one of the dominant forms of life across the entire supercontinent, ruling landscapes that stretched from coast to coast. Their evolutionary success also completely reshaped the ecosystems around them in profound ways. As synapsids evolved innovative new methods of feeding and hunting, they forced their prey and competitors to adapt as well or face extinction. This constant evolutionary pressure created a dynamic, ever-changing world where survival meant keeping pace with the relentless arms race of life itself. In this way, the mammal-like creatures of Pangea laid the crucial groundwork for many traits that would eventually define their distant descendants: warm-bloodedness, efficient movement, and complex social behaviors that we still see in mammals today. Even during the height of their dominance, however, the world around them was shifting in dramatic ways. Massive volcanic eruptions sent choking ash high into the atmosphere. Powerful tectonic forces strained the supercontinent, subtly but continuously reshaping its landscapes. The atmosphere itself fluctuated wildly, with oxygen levels rising and falling like a planetary heartbeat. Through all of these challenges, the synapsids endured with remarkable resilience. They weren't yet true mammals, but they carried the genetic blueprint of what mammals would eventually become. To stand on Pangea and watch them move confidently across the land would have been to glimpse the early outlines of a future still hundreds of millions of years away. Their powerful jaws, sturdy limbs, and incredible ability to survive in a world of brutal extremes marked them as the quiet architects of what was destined to come. They weren't the largest creatures in their world, nor necessarily the most terrifying, but they were among the most enduring, and in the harsh, restless age of Pangea, endurance was absolutely everything. Beneath Pangaea's vast surface, the Earth was never truly still or at peace. Its crust remained locked in a constant violent struggle with the immense forces rising from far below. Heat built relentlessly deep within the mantle, driving the slow but absolutely unstoppable movement of massive tectonic plates. Along the seams where ancient continents had violently fused together, the ground buckled and split under enormous pressure, and from those gaping cracks, fire emerged like Earth's blood. Volcanoes served as the pulse of the planet itself, and during the age of Pangea, their overwhelming presence was completely inescapable. These weren't isolated peaks scattered randomly across the landscape like modern volcanic systems. Many rose dramatically along great fault lines where tectonic plates met in violent collision, forming chains that stretched for hundreds, even thousands of kilometers like fiery mountain ranges. In some regions they erupted steadily and predictably, releasing endless rivers of molten lava that gradually hardened into brand new rock formations. In others, their explosions were sudden and absolutely catastrophic, sending massive clouds of ash and poisonous gases high into the atmosphere, dramatically altering the climate for years at a time. The evidence of this incredible volcanic activity remains clearly visible even today. Ancient lava flows, preserved perfectly in layers of stone, trace the exact outlines of long-dead volcanoes like geological fingerprints. Beds of volcanic ash lie buried deep in the rock record, serving as silent witnesses to the fury of a world still being violently forged by internal forces. These eruptions weren't rare, isolated events that happened once every few million years. They were a regular, constant part of daily life on this restless supercontinent, shaping every aspect of existence for the creatures that called Pangea home. The impact of this relentless volcanic activity on Pangea was absolutely profound and far-reaching. Each major eruption completely reshaped the surrounding land, carving out entirely new mountain ranges and burying vast valleys beneath layers of hardened basalt. Enormous plateaus formed gradually from layer upon layer of cooling lava, their surfaces later carved and eroded by wind and rain into rugged alien landscapes. In the shadow of these volcanic regions, soils enriched by mineral-rich ash fed explosive new plant growth, creating unexpected patches of incredibly fertile ground amid otherwise harsh and unforgiving environments. Yet volcanoes accomplished far more than simply reshaping the physical landscape. They completely transformed the very air itself. Each eruption released absolutely vast amounts of gases into the atmosphere, including water vapor, carbon dioxide, and various sulfur compounds that could change everything. Carbon dioxide in particular acted as an incredibly powerful greenhouse gas, trapping heat efficiently and amplifying the planet's already intense and extreme climate conditions. Over millions of years, these constant emissions played a crucial role in driving the dramatic temperature shifts that defined Pangaea's environmental extremes, creating the scorching deserts and lush forests that characterize different regions. Sulfur gases, on the other hand, could produce exactly the opposite effect in the short term, creating a complex atmospheric dance of heating and cooling. Imagine a world where the sky could turn black in minutes, where the ground beneath your feet trembled with the heartbeat of an angry planet. This was Pangea, Tea's supercontinent so volatile that survival meant adapting to nature's most extreme tantrums. Picture this: massive volcanic eruptions launching clouds of sulfur so high into the atmosphere that they acted like a planetary mirror, bouncing sunlight back into the void of space. The result? Sudden dramatic cooling that could plunge entire regions into an unexpected chill. But here's where it gets wild, these same volcanoes that cooled the planet could also warm it, creating a climate so unpredictable that every creature living there was essentially gambling with their existence. Think about the sheer scale of this chaos. One volcanic eruption could flip Pangaea's entire climate like a switch. Warm became cold, cold became scorching, and everything alive had to roll with these planetary mood swings or face extinction. This wasn't just weather mire. This was geological warfare on a scale we can barely comprehend today. But the real drama was just beginning. Those resin-heavy conifer forests that blanketed much of Pangea, they were basically giant tinderboxes waiting for a spark. Lightning from volcanic storms would strike these ancient woods, and when it did, the fires that followed weren't just forest fires, they were continent-spanning infernos that could be seen from space. These weren't random disasters, though. Fire became Pangea's renovation tool, sweeping away old growth and creating space for entirely new ecosystems to emerge. Imagine vast stretches of charred landscapes slowly transforming into lush green paradises, only to burn again in an endless cycle of destruction and rebirth. For the creatures trying to make a living on this volcanic playground, every eruption was a double-edged sword. When ash clouds blocked out the sun, plants withered and died, forcing massive herds of herbivores to embark on desperate migrations searching for food. And wherever prey animals went, predators followed, turning these migrations into moving battlefields where only the strongest survived. Standing on Pangea during this incredible transformation would have felt like witnessing the birth pangs of our modern world. Imagine feeling subtle tremors beneath your feet as distant volcanoes rumble to life, their power rippling through the supercontinent's massive frame. Picture rivers slowly but steadily carving deeper channels through widening rift valleys, each year cutting a little further as the land literally pulled itself apart. Watch mountains thrust skyward where the Earth's crust buckled and twisted under unimaginable geological pressure. This was a planet caught between two worlds, the unified supercontinent it had been for millions of years, and the scattered continents it was destined to become. Yet here's what's truly remarkable. Even as these first cracks appeared, Pangea was far from finished. The supercontinent would persist for millions more years, its ecosystems constantly adapting, life flowing like water into every newly formed valley and emerging highland. But what really held this colossal landmass together wasn't just geology, it was something far more dynamic and life-giving. Picture this, a network of rivers so vast and interconnected that they made today's river systems look like backyard streams. These weren't just waterways, mind. They were the circulatory system of an entire world, pumping life across distances that would span multiple modern continents. Think about the sheer scale we're talking about here. While today's rivers are confined by oceans and continental boundaries, Pangea's waterways knew no such limits. They flowed freely across what would eventually become North America, Africa, Europe, and Asia, creating one massive unbroken water network that connected every corner of the supercontinent. These aquatic highways began their journeys high in the towering mountain ranges that had been thrust up when the ancient continents first collided to form Pangea. Snowmelt and rainfall from these peaks created torrents that sliced through solid rock like nature's own power tools, grinding down minerals and sediments over millions of years. As these waters descended from the heights, they transformed into mighty rivers that snaked through forests and plains, gathering strength as countless tributaries joined their ranks. But here's where it gets truly spectacular. These weren't just water sources, they were civilization builders along their banks. Life exploded in abundance. Massive conifers and sprawling seed ferns created lush corridors that stretched for thousands of kilometers, their root systems acting like natural engineering projects, holding soil in place while their fallen leaves created rich, fertile ground. The activity along these riverbanks would have been absolutely mind-blowing. Swarms of ancient insects filled the air above shallow backwaters, creating living clouds that buzzed with constant motion. Primitive amphibians lurked in the muddy shallows and reed beds, ambush predators waiting for their next meal. Agile reptiles patrolled the water's edge, some hunting insects, others diving into the currents to escape larger threats. Picture this. Millions of years ago, there was no silence hanging over the massive supercontinent we call Pangea. Instead, the atmosphere itself was alive, speaking in a complex dialogue of rushing winds, powerful storms, and constantly moving air masses that sculpted everything beneath them. If you could somehow travel back and stand on that ancient ground, you'd be surrounded by the sounds of an entire world breathing, its enormous presence creating an endless symphony of weather patterns that never stopped moving from one edge of the horizon to the other. The winds themselves were like nothing we experience today. Imagine having almost every piece of land on Earth crammed together into one gigantic continent. This meant there was practically nothing to slow down or redirect the massive air currents that started their journey over the vast Panthalas Ocean. These incredible wind systems could race across thousands upon thousands of kilometers of Pangea's surface before finally losing their power. When they first hit the coastal areas, they were loaded with ocean moisture, rushing through dense forests and making the tops of massive conifer trees sway and bend. But as these same winds pushed deeper into the continent's heart, they transformed completely, becoming bone-dry currents that screamed across endless desert landscapes, picking up sand and dust until the entire horizon disappeared in a hazy blur. Every single region of this supercontinent had its own unique relationship with these winds, and together they created Pangea's distinctive voice. But this voice could change dramatically depending on the season. When the monsoons arrived, everything became amplified. The scorching heat rising from Pangea's interior acted like a massive vacuum, sucking in enormous walls of moisture-heavy air from the surrounding ocean. These monsoon winds didn't just bring rain, they brought absolute deluges that hammered the forests and swelled the rivers until they burst their banks and flooded vast plains. The aftermath of these monsoons was equally dramatic. The humid, steamy air that followed became thick with swarms of insects, while countless amphibians and reptiles emerged from their hidden refuges to take advantage of the abundance. For weeks at a time, the entire sky seemed to pulse with activity, wind roaring, water rushing, and the constant drumbeat of raindrops striking millions of leaves. Then, as suddenly as they had arrived, the monsoons would retreat, leaving behind a completely different world. The dry seasons brought their own character to Pangea's atmosphere. Winds that had been stripped of every drop of moisture would sweep across the continent's core, their movements creating haunting sighs as they passed over sand dunes and rocky wastelands. During these periods, the sky above the desert regions must have felt impossibly vast and empty, a pale, cloudless dome stretching endlessly in every direction, with air that shimmered and danced in the brutal heat. When night finally came to these desert regions, the entire scene would transform into something almost magical. The oppressive heat would fade, replaced by a crystal-clear canopy of stars more brilliant than anything we can imagine today. The only sounds breaking this cosmic silence would be the soft whistle of wind threading between rocks and the occasional calls of creatures that had evolved to thrive in the darkness. Storms added yet another dimension to this ancient atmospheric theatre. With such incredible distances to build their power, and such massive wind patterns to feed them, thunderstorms could grow to absolutely staggering proportions. Their towering anvil-shaped clouds would punch high into the stratosphere, creating lightning displays that split the sky with jagged, brilliant flashes. The thunder that followed would roll across the open landscape for miles and miles without any obstacles to stop it. Near the coastal forests, these monster storms would unleash torrential downpours, but in the bone-dry interior regions, the same storm clouds would often pass overhead like cruel teasers, their rain evaporating before it could reach the ground. A constant reminder of just how far Pangea's heart lay from the ocean's life-giving moisture. The volcanic activity along Pangea's rift zones contributed its own terrifying voice to this atmospheric symphony. When these volcanoes erupted, they didn't just affect the local area, they sent massive columns of ash and toxic gases soaring high above the continent, where the winds would grab them and spread them across thousands of kilometers. These volcanic events could literally turn day into an eerie twilight, blocking out the sun behind curtains of grey ash. Lightning would crackle and dance within these ash clouds, creating supernatural storms of fire and debris that would echo across the landscape for days on end. But Pangea's sky wasn't just about these dramatic, violent moments. It also carried much gentler but equally important messages. Soft breezes became the delivery system for plant spores and the seeds of early conifer trees, carrying them far from their parent plants to establish new forests in distant lands. Migrating animals learned to read the seasonal wind shifts like a calendar, timing their movements to work with the changing climate patterns rather than against them. Even the dust storms that raged through the interior deserts served a vital purpose in this ancient world. These storms would lift countless tiny particles high into the atmosphere and then scatter them across forests and wetlands thousands of kilometers away, essentially delivering a package of minerals and nutrients from distant lands to enrich soils that might otherwise have been depleted. In this incredible world, the sky was never just a backdrop or something to ignore. It was a living, active participant in Pangea's entire ecosystem, serving as the crucial connection between ocean and land, between desert and forest. Every single change in temperature or atmospheric pressure would ripple outward like waves, affecting everything and everyone beneath it. If you could have stood on the banks of one of Pangea's mighty rivers and simply listened, you might have heard the constant buzz of insects hanging in the still air, the gentle sighing of wind moving through conifer branches, and somewhere in the distance, the low, threatening rumble of thunder building in a storm still far away. In the interior desert regions, you might have experienced a silence so profound and complete that it was broken only by the dry scraping of air moving over sand and the sound of your own breathing. Near the coastal areas, the wind would have carried the sharp smell of salt water mixed with the calls and cries of creatures living in that magical zone where forest met sea. Day after day, season after season, this ancient sky continued writing its story across the land, shaping every climate zone and influencing every form of life. This atmospheric rhythm wasn't chaotic or random. It was steady and reliable, following patterns older than mountains, older than rivers, older even than Pangea itself. And while the continents would eventually drift apart and new skies would form above them, the voice of that original atmosphere still whispers to us today in the rock layers, in fossilized remains of ancient forests and deserts, and in the very wind patterns that continue to circle our planet. For millions upon millions of years, Pangea flourished under this vast sky, its rivers flowing, forests growing, deserts shifting, and coasts evolving, creating a world filled with absolutely extraordinary life forms. But here's the thing about our planet. Nothing ever stays the same forever. The same Earth that nurtures and supports life also puts it through the most severe tests imaginable. And during the late Permian period, those tests became absolutely devastating. This was the era of fire and deadly silence, when the most catastrophic extinction event in our planet's entire history struck like a hammer blow and nearly wiped Pangea clean of its living inhabitants. The Permian Triassic extinction, which scientists often call the Great Dying, was unlike anything that had happened before or has happened since. Around 252 million years ago, the Earth itself seemed to convulse violently. Massive volcanic eruptions, particularly in what we now call Siberia, began pouring out volumes of lava and poisonous gases that are almost impossible to comprehend. For hundreds of thousands of years, these eruptions completely transformed the atmosphere. Thick clouds of ash blocked out the sunlight. Sulfur compounds and carbon dioxide choked the sky. The very air became heavy with the toxic breath of a world in absolute crisis. Global temperatures began climbing to lethal levels. The volcanic eruptions weren't just creating spectacular displays of fire and ash. They were fundamentally changing the planet's entire climate system. Massive amounts of greenhouse gases were being pumped into the atmosphere, trapping heat like an enormous blanket wrapped around the Earth. This pushed our planet into one of the most scorching periods in its entire 4.5 billion year history. Pangea's interior, which was already a land of brutal extremes, became almost completely uninhabitable. Rainfall became increasingly rare, then practically non-existent in many regions. Rivers that had flowed for millions of years simply dried up and disappeared. The already massive desert regions began expanding relentlessly, swallowing up areas that had once been green and alive, reaching farther across the supercontinent than ever before in its history. But the devastation wasn't limited to the land. The oceans surrounding Pangea were suffering their own catastrophic transformation. The extreme heat was literally sucking oxygen out of the seawater, creating enormous dead zones where nothing could survive. Marine life was essentially suffocating on a global scale. These deadly effects spread like ripples through every single ecosystem on the planet. The magnificent forests that had once thrived near Pangea's coasts began withering away, their leaves turning brown and falling in massive drifts. Many of the great synapsids, those incredible mammal-like reptiles that had been the undisputed rulers of their world, simply vanished forever. Even insects, which had been absolute champions of survival for hundreds of millions of years, experienced something almost unthinkable, a sudden and completely catastrophic collapse. This was one of the only known mass extinctions in insect history, which tells you just how severe this crisis truly was. Amphibians, who had once been the kings and queens of Pangea's waterways, found themselves pushed to the very brink of extinction as droughts and killer heat waves drove them into the few remaining refuges where they could barely survive. But here's something absolutely remarkable about life on our planet. It never gives up. It never completely ends. While the vast majority of species were being wiped out, a small but determined group of survivors managed to cling to existence in the scattered safe havens that remained. Some of the smaller synapsids, creatures that had been built for maximum efficiency rather than impressive size, somehow managed to weather this incredible storm. Their compact bodies were actually their secret weapon. They needed far less food and water to survive, giving them a crucial advantage in a world that had been stripped of almost all abundance. Early reptiles also proved to be remarkably tough survivors, particularly those species that had already adapted to harsh, dry conditions. Their thick, protective skin, powerful lungs, and incredibly efficient water-conserving physiology gave them exactly the tools they needed to outlast the chaos that was destroying everything around them. Even in the dying oceans, life found a way to persist. While countless species of fish and invertebrates disappeared forever, a few remarkable survivors actually adapted to the low oxygen waters, essentially holding their breath until the seas could slowly begin to recover. The plants of Pangea also had their champions. The towering forests were reduced to scattered remnants, but hardy conifers and drought-tolerant species managed to endure, ready to spread across the landscape again once the skies finally began to clear. These survivors shared something fascinating. They weren't the largest, most impressive, or most dominant creatures of their time. Instead, they were the quiet ones, the incredibly resilient ones, life forms that had learned how to bend without breaking when the world tried to destroy them. The recovery process was agonizingly slow. For millions upon millions of years, our world remained deeply scarred by what had happened. The once lush landscapes of Pangea were sparse and empty, dominated by small, incredibly tough plants and the scattered remnants of animals that had somehow made it through the apocalypse. But something amazing was happening in this apparent silence. A completely new order was beginning to emerge. The survivors weren't content to just exist. They began to diversify, spreading out to fill all the empty spaces that extinction had left behind. Small synapsids started evolving into entirely new forms, many of them developing traits that would eventually define what we now know as mammals. Reptiles, suddenly freed from most of their competition, exploded into new ecological niches, setting the stage for what would eventually become the rise of the very first dinosaurs. This extinction event reshaped Pangea, not just in terms of what was living there, but in the fundamental balance of its entire ecosystem. Where dense forests had once stood and rivers had once been crowded with amphibians and insects, the land now stretched wide and open, ready for the pioneers of the Triassic period. These were creatures built specifically for a much harsher Earth, descendants of the few that had somehow endured the extreme heat and desperate hunger of the Great Dying. Their world was definitely quieter and emptier than what had come before, but it was also absolutely overflowing with opportunity. Even the sky itself would have seemed completely different after this catastrophe. Without vast forests to pump moisture into the atmosphere, rainfall patterns shifted dramatically across the supercontinent. Dust from the expanding deserts could now spread much farther than before. The air was thinner, drier, and often hazy with lingering traces of volcanic activity that seemed to go on forever. It was definitely a humbler world than what had existed before, but it was ready to begin writing an entirely new chapter. In the silence that followed the Great Dying, evolution went to work with incredible patience. The survivors of Pangea might not have been the giants of earlier ages, but they were carrying something precious, the seeds of what was yet to come. In their smallness and their amazing ability to endure, they represented a completely new kind of life, one defined not by dominance or size, but by pure, stubborn persistence. These survivors would rebuild the ecosystems of the supercontinent piece by piece, and eventually they would give rise to the next great chapter of Earth's incredible history. The world had been broken almost beyond recognition, but it was definitely not dead. Out of that profound stillness, new life would rise, and Pangea, though forever changed, would remain the stage upon which this amazing drama would continue to unfold. When the silence after the Great Dying finally began to fade, Pangea emerged as both a scarred and incredibly promising world. The supercontinent had been stripped of much of its former abundance, but its enormous scale and vast empty spaces offered something truly extraordinary, a completely fresh beginning. What had survived would go on to shape the entire future of life on Earth, and the unique geography of Pangea itself would determine exactly how that future would unfold. With nearly all of Earth's land gathered into one immense mass, there were no oceans to isolate different species from one another. The survivors of the Permian extinction, small synapsids, incredibly resilient reptiles and hardy plants, suddenly had a single continuous stage that stretched across almost the entire planet, giving them room to spread and explore. Populations could travel across absolutely vast distances without ever needing to cross a sea or major water barrier. This incredible freedom of movement allowed life to mix and mingle in ways that would have been completely impossible on a divided planet. A creature that first evolved in what we now call South America could simply wander northward into regions that would one day become North America, or even head east toward areas that would later become Europe or Asia, leaving its descendants scattered across half the world. This amazing interconnectedness actually accelerated evolution at a rate never seen before. When species met each other, they competed. When they competed, they adapted and changed. Pangea had become a vast natural laboratory, a place where every change in climate, every shift in the landscape, and every new adaptation would ripple outward like waves, influencing life across the entire supercontinent. This is exactly why the Triassic period, which followed the Permian extinction, became such an incredible age of experimentation. The world was absolutely full of ecological vacancies, and evolution rushed to fill every single one of them. Small synapsids that had survived in the margins of the old world began diversifying into completely new forms, some of them moving closer to what we would eventually recognize as the earliest mammals. They remained small, mostly insect eaters, scurrying through the undergrowth of Pangea's slowly recovering forests. Their small size wasn't a disadvantage at all. In a land still recovering from disaster, being small was actually a tremendous strength. It meant they needed very little food, could easily hide from predators, and could exploit countless overlooked corners of the supercontinent's rebuilding ecosystems. Reptiles also seized this incredible moment in Earth's history. Suddenly freed from many of their former competitors, they evolved into an absolutely staggering variety of shapes and sizes. Some became swift, incredibly agile predators that could chase down prey across the open landscapes. Others grew much bulkier, transforming into the first large herbivorous reptiles that would roam the plains and river valleys of Pangea, essentially becoming the lawnmowers of their ancient world. Hidden among these early survivors were the ancestors of creatures that would eventually become legends, the first true dinosaurs. At this point in history, they were still small and seemingly unremarkable. Nothing that would hint at their future dominance, but they were already carrying the genetic potential to rule the planet in the incredible ages that lay ahead. Plants were playing an equally crucial role in rebuilding this transformed world. The forests of Pangea, though forever changed by the Great Dying, began spreading once again across the coastal regions and river valleys. Hardy conifers started reclaiming the upland areas, their tough evergreen needles perfectly designed to handle the dramatic seasonal swings that characterized the supercontinent's climate. Seed ferns and cycads took root in the warmer regions, their robust forms providing essential food for the growing populations of herbivorous animals that were slowly repopulating the landscape. Even the bone-dry interior of Pangea managed to support scattered patches of incredibly hardy vegetation, small oases of green that became vital stepping stones for life attempting to move across the vast desert regions. The unique geography of Pangea continued to influence the planet's climate in ways that directly shaped how evolution would proceed. The massive interior remained dry and brutally harsh, naturally favoring animals and plants that had developed the ability to endure extreme heat and prolonged droughts. Along the coastal areas where ocean winds could still bring life-giving rain, ecosystems were much more stable and abundant, capable of supporting larger, more diverse communities of plants and animals. This dramatic contrast between the harsh interior and the more hospitable coasts ensured that no single type of life could dominate everywhere across the supercontinent. Instead, evolution was forced to carve out highly specialized solutions for every different corner of this vast landmass. The great rivers of Pangea played their own crucial role in shaping the continent's future. These massive waterways functioned like highways of life, serving as vital corridors that linked distant regions and allowed species to spread much farther than they otherwise could have managed. In their fertile floodplains, rich soils supported incredibly dense vegetation, and these green belts became natural migration routes for countless species. Fossil evidence that we can study today shows something remarkable. Creatures living on completely opposite sides of Pangea often shared striking similarities, providing solid proof that these river corridors truly did connect the entire continent like threads woven through an enormous web of life. But here's something fascinating. Even as Pangea displayed this incredible unity, it was simultaneously planting the seeds of its own division. The first rift valleys that would eventually tear the supercontinent apart were already beginning to form, slowly but surely. These developing rifts were creating isolated habitats where populations of plants and animals became separated from one another for the first time in hundreds of millions of years. Over the course of millions of years, this gradual isolation would lead to the emergence of entirely new species, each one perfectly adapted to its own unique environment, each one carrying forward a distinct piece of Pangea's incredible biological legacy. The supercontinent's influence would reach even further into the future than anyone could have imagined. The animals that had managed to spread across its vast expanse, those early reptiles, mammal-like synapsids, and the first true dinosaurs would go on to dominate not just Pangea itself, but also the smaller continents that would eventually emerge when the supercontinent finally split apart completely. The forests and deserts that covered Pangea would fundamentally shape the evolution of plant life that still has direct descendants living on our planet today. Even the climate patterns that developed across the supercontinent would leave permanent marks in the geological record that scientists can still trace and study, serving as a powerful reminder of how profoundly this single massive landmass once controlled virtually all of Earth's systems. To stand on Pangea during this remarkable time would have been to witness a world caught in the middle of an incredible transformation. The scars left by the Great Dying were still clearly visible across the landscape, but life was definitely returning, cautious and careful at first, then becoming completely unstoppable. The sound of wind rushing through recovering conifer forests, the fresh tracks of small reptiles pressed into the mud along riverbanks, and the distant calls of predators echoing across the landscape were all living proof of a planet actively rebuilding itself from the ground up. Pangea was so much more than just a supercontinent. It was a crucible, a testing ground where life was forged and refined. From its extreme climate conditions, its incredible vastness, and its unique connectedness, it created the fundamental foundations of the modern world we know today. Everything that came after, from the spectacular rise of the dinosaurs to the emergence of the first true mammals and eventually to our own species, was shaped in some profound way by the land and climate of this ancient unified Earth. For countless millions of years, Pangea had been the absolute center of everything that mattered. Its vast deserts, mighty rivers, recovering forests, and towering mountains stretched endlessly beneath a single unifying sky. All of its life could roam freely across a land that knew no borders or barriers. But even as it continued shaping the future of our entire planet, the first deep fractures had already begun appearing. Slowly and almost silently at first, the supercontinent that had united the world started the long process of breaking apart. This wasn't a sudden dramatic event. It unfolded over tens of millions of years, driven by exactly the same powerful forces that had once brought all the continents together in the first place. Heat was building deep within the Earth's mantle, pressing upward with enormous force against the crust above. Massive rifts began opening, splitting the land into great valleys where lava welled up from the planet's molten interior. These rifts were the very first hints of separation, the earliest marks of the continental map we recognize today. In the regions that would one day become the Atlantic Ocean, cracks started appearing between what we now know as North America and Africa. At first, these weren't oceans at all, but rather long, low basins dotted with lakes and rivers. Over enormous spans of time, these basins gradually deepened. Water from Panthalassa began creeping in, filling the growing rifts, and the first narrow seas were born. On the opposite side of Pangea, the land that would eventually become India, Australia, and Antarctica began drifting slowly away from Africa, pulled inexorably by the same massive tectonic forces that were reshaping the entire planet. These gradual changes didn't just reshape the land, they completely transformed the climate as well. As Pangea continued fracturing, entirely new coastlines formed, and with them came fresh sources of life-giving moisture. Regions that had been dry for millions of years suddenly began receiving rain from the growing oceans. The enormous interior deserts that had stretched unbroken across the heart of the supercontinent gradually began shrinking. Meanwhile, other areas grew increasingly drier, cut off from humid winds by rising mountain ranges or by the constantly changing positions of the drifting landmasses. Life responded to these changes in remarkable ways. Species that had once roamed freely across all of Pangea suddenly found themselves divided by widening seas and growing rift valleys. Populations became isolated, separated from one another by geography for the first time in hundreds of millions of years. From this enforced isolation, entirely new species began emerging. The ancestors of familiar lineages, dinosaurs, early mammals, and the first true crocodiles, evolved in these newly divided worlds, each group adapting to the new realities of a planet that was no longer whole. The breakup of Pangea also fundamentally changed the oceans themselves. As the Atlantic continued widening, it became a completely new pathway for currents that would eventually reshape the planet's entire climate system. Panthalassa, which had once been the single vast ocean surrounding Pangea, now began sharing its dominance with new seas that carved their way deep into the fragmenting supercontinent. These changes would influence not only weather patterns and rainfall, but also the migration routes of marine life, opening up brand new habitats while closing others forever. On land, intense volcanic activity accompanied this slow separation. Along the active rift zones, magma surged upward with tremendous force, creating vast lava flows and completely reshaping the landscape. These massive eruptions released enormous amounts of gases into the atmosphere, sometimes warming the planet even further and driving dramatic swings in climate patterns. The land that had once been united under a single predictable rhythm of wind and weather was now becoming a complex mosaic of smaller worlds, each one developing its own emerging character and unique identity. For the incredible creatures living during this monumental time, these gradual changes were absolutely life-altering. Dinosaurs, which had first emerged when Pangea was still a unified supercontinent, now began spreading across the slowly drifting landmasses, constantly adapting to the evolving climates and dramatically shifting landscapes as the landmasses pulled farther and farther apart. Early mammals were following remarkably similar paths, discovering their own safe havens in the forests and along the fertile river valleys of these newly forming continents. What had once been a single, completely interconnected world was slowly splintering into fragments, setting the stage for the incredible diversity that would come to define the entire Mesozoic era. If you could have somehow stood on Pangea during its incredibly long goodbye, you probably wouldn't have noticed any change from one generation to the next. The ground beneath your feet would have felt completely solid and permanent. The vast forests would still have stretched endlessly toward every horizon. The mighty rivers would have continued their eternal flow toward the sea. But over the course of millions upon millions of years, those barely visible cracks gradually deepened into massive valleys. The narrow seas slowly widened into enormous oceans, and the single greatest landmass in Earth's history was quietly transformed into the world of separate continents that we recognize today. This wasn't really an ending at all. It was more like a profound transition. Pangea had given life an unprecedented opportunity to spread, to evolve, and to mix in ways that no other arrangement of continents could ever have allowed. Its slow, methodical breakup didn't erase that incredible legacy. Instead, it carried that legacy forward, distributing the descendants of Pangea's creatures across entirely new lands and completely different climates, where they would continue changing and adapting for millions of years to come. The supercontinent had begun its long final farewell, but its profound influence would echo far beyond its own remarkable lifetime. Permanently written into every ocean current, every mountain range, and every living thing that still walks our planet today. Even though Pangea vanished from the Earth long ago, its presence has never truly abandoned us. The continents we see today, split apart by vast oceans and scattered across the globe, are still fundamentally shaped by its ancient memory. The mountains, rivers, deserts, and even the living creatures that walk the Earth all carry unmistakable traces of that extraordinary time when our entire world was unified as one. The echo of this single unified Earth continues to linger in the land beneath our feet, and in the intricate patterns of life that connect us to a much more ancient history than most people realize. You can actually see this echo preserved in the rocks themselves. The Appalachian Mountains of North America share their ancient geological roots with the highlands of Scotland and the peaks of Morocco. Once upon a time, they were all part of the same massive mountain range, thrust high into the sky when Pangea was first forged by colliding continents. Their towering peaks once stood shoulder to shoulder before slowly drifting apart over millions of years. Today they're separated by the entire Atlantic Ocean, but their stone still tells exactly the same story. Their rock layers remain perfectly aligned like pieces of an enormous puzzle that was pulled apart but never completely forgotten. You can hear this same story in the fossils that scientists continue to discover. Creatures that once roamed freely across the entire supercontinent left their bones scattered from one end of our world to the other. Identical species of early reptiles, the same types of plants, even the same insects appear in rock formations on continents that are now divided by entire oceans. They remain as silent witnesses to an incredible time when no sea stood between them, when the Earth was a single unbroken stage for life to perform its magnificent story. Even the winds and waters that surround us today still carry Pangea's unmistakable mark. The great ocean currents that circle our planet can trace their origins directly back to the first openings of the Atlantic and Indian Oceans, born from the massive fractures that split the supercontinent apart. The monsoon patterns that bring life-giving rains to South Asia and Africa are shaped partly by the current positions of these drifting continents, remnants of movements that began when Pangea first cracked and slowly drifted into separate pieces. And life itself has definitely not forgotten its origins. The ancestors of mammals, dinosaurs, and countless other evolutionary lineages were all molded and shaped by the unique conditions that existed on Pangea. Its vast, unforgiving deserts hardened creatures to endure extreme drought and scorching heat. Its endless forests provided shelter for small survivors who would eventually become the first true mammals. Its mighty rivers and extensive coastlines taught life how to move, how to spread, and how to adapt to a planet where the fundamental rules of survival were constantly being rewritten by shifting climates and restless ground. Even in our own human bodies, in the deep structure of our bones and the genetic memory written into our cells, there exists a connection, an unbroken evolutionary line that runs back through millions of years to that single unified world. The echo of Pangea isn't just some fascinating relic of the distant past. It's an active force that continues to shape our present reality. Every mountain range that rises from the earth, every earthquake that shakes the ground beneath our feet, every gradual drift of continents is part of the same endless cycle that built and then broke apart that ancient world. We're living on a planet that's still in constant motion, still carrying the restless energy that once drew all the continents together and then slowly pushed them apart again. If you could somehow stand on the highest peak on Earth today and look out across our world, you would see a planet divided by massive oceans and separate continents. But if you look deeper beneath the surface, beneath the arbitrary lines we draw on our maps, you would discover the same foundation, the same ancient stone that once formed the floor of a single unified Earth. And if you listen very carefully to the slow grinding of tectonic plates and the distant roar of the sea, you can still hear it, the low, steady echo of a world that was once completely whole. Pangea is gone forever, but it's also everywhere around us. It exists in the mountains that were born from its violent collisions, in the creatures that evolved upon its soil, and in the quiet, unending drift of continents that will one day gather together again. Our Earth has never stopped moving, and as it continues to turn and shift, it carries with it the permanent memory of that time when all land was one, when every horizon was connected, and when the sky arched unbroken above a single boundless world. And so, the incredible story of Pangea doesn't end with its disappearance from our planet. It continues to linger in every mountain range, every current of wind, and every living thing that can trace its lineage back to that ancient, unified Earth. We walk across land that was once joined together, breathe air that was shaped by the forests that once covered it, and study fossils of creatures that roamed a world without any borders. Pangea reminds us that our planet has never been still or static. Continents drift across the surface. Oceans open and close, like enormous doors, climates shift and change, and life constantly adapts to new challenges. What was once one world became many separate worlds, and in the distant future, those many worlds may one day converge and become one again. Our Earth is constantly rewriting its own story, and absolutely everything we see around us today represents just one chapter in an epic tale that began countless eons before our existence, and will continue unfolding long after we're gone. If there's a powerful lesson to be learned from Pangea, it's that change isn't the exception to some rule, change is the rule itself. Yet woven throughout all that constant transformation is an unbreakable thread, a profound connection that links the world we inhabit today to the deepest, most ancient past imaginable. When we examine a map of our modern Earth with its scattered continents and vast oceans stretching between them, it's incredibly easy to see only distance and separation everywhere we look. But hidden beneath those seemingly dividing seas, in the slow, patient movement of the planet's crust and the shared history that's been carved permanently into stone, our Earth is still fundamentally one unified system. Pangea wasn't simply a place that existed millions of years ago. It was a remarkable moment in our planet's history, when the Earth literally gathered itself into a single, complete whole. And even though that incredible world has vanished forever, its echo continues to live on with us, carried silently in the ground beneath our feet and in the restless, never-ending motion of the Earth itself. The continents will continue their eternal drifting across the planet's surface. The sky will keep shifting and changing its patterns above us, and the memory of Pangea will endure as an ancient reminder that our world has always been far larger, far stranger, and infinitely more connected than it ever appears to be on the surface. This single supercontinent teaches us something profound about our planet and our place on it, that what seems permanent is actually temporary, what appears separate is actually connected, and what looks finished is actually just beginning. Pangea's story is ultimately our story too, written in the rocks we stand on, flowing in the winds we breathe, and continuing in the ground that's still moving beneath us right now.